Bismillahirrahmanirrahim. My name is Ayeza Shehzad and I'm in grade 7 and the topic of my presentation is the science behind tsunamis. What is a tsunami and how does it form? A tsunami, the Japanese word meaning a harbor wave, is a series of long waves caused by a large sudden displacement of the ocean, usually the result of an underwater earthquake, volcanic eruption, landslide, explosion, the collapse of rocks, glaciers, or even asteroids impacting the water. This force creates waves that radiate outwards in all directions away from the source, sometimes crossing entire ocean basins. Here are a few diagrams of how tsunamis can occur. The first one shows how a tsunami is made by a volcanic eruption. The second one shows how a tsunami is made by an asteroid impact. The third one shows how a tsunami is made by erosion. And the last and most common one shows how a tsunami is made by an earthquake. What causes tsunami waves to decrease velocity as they move towards the shoreline? Well, when the tsunami reaches shallow water, wave shoaling occurs. Because there is less water to move through, this massive amount of energy is compressed. Then the wave speed slows down while its height rises to as much as 100 feet, creating the destructive tsunami. The objective of this demonstration is to investigate and model the effect that water depth has on wave velocity. I hypothesize that the velocity of tsunami waves will depend on water depth. As the water depth increases, the wave velocity will increase as well. The materials you will need for this experiment are a water tank or a plastic container, some water, a piece of wood, a permanent marker, a stopwatch, a ruler, a lab notebook, a volunteer, and some food coloring. Now here's the procedure for my experiment. The first step is to move any items away from the place at which you will be testing that could be damaged by water, as there might be a little splashing caused by the water. Place the water tank on a white or light colored surface. This will let you see the waves clearly. I also added some food coloring for the same purpose. The next step is to fill the water tank until you have 1 centimeter of water in the tank. Use a ruler for accuracy. Create a data table in your lab notebook, like the one I have created below. Have your volunteer ready with the stopwatch to start timing how long it takes a wave to travel from one end of the tank to the other. Hold the bottom of the wooden block that is at least a few centimeters above the water. As soon as you drop the block and a wave is created, the volunteer should start the stopwatch. The volunteer should stop the stopwatch when the wave hits the other end of the tank. Record the time in the data table in your lab notebook. Now, fill the water tank until the water depth is 2 centimeters. Use the ruler to confirm the water depth. Try to drop the block the same way you dropped it before each time. Record all the data in the data table in your lab notebook. Now, fill the water tank until the water depth is 3 centimeters. Use the ruler to confirm the water depth. Record all the data in the data table in your lab notebook. Lastly, empty the tank and repeat steps 4 to 7 2 more times so that you have a total of 3 trials for each depth. Be sure to record all the data in the data table in your lab notebook. Now here is a video of me dropping the wooden block into the water. The wooden block represents an asteroid falling from above, and the water represents the ocean. It's time to analyze my data. Here are the results of my experiment. I have also created an equation based on my experiment. This equation shows the mathematical relationship between the wave velocity in shallow water as a function of water depth. And it states that velocity is the square root of the product of the acceleration of gravity and water depth. Conclusion. I predicted that the wave velocity would increase as the depth of the water got deeper. As you previously saw from the results of my experiment, my hypothesis was correct. Therefore, the speed of a tsunami depends on the depth of the water it is traveling through. The deeper the water, the faster the tsunami. As a result, in the deep ocean, tsunamis can move as fast as a jet plane over 500 miles per hour and can cross entire oceans in less than a day. Thank you for listening to my presentation. Jazakallah.